Next proof. We're given that FC is perpendicular to BE. We're given that FC is perpendicular to BE. Hey. I'm in the middle of recording a video for my students right now. It's fine. I can just edit this out. But can I call you back in like maybe 20 minutes?
Sure.
Okay.
You didn't have to answer. You could have just...
I know, but I figured I was going to cut out the piece that had the phone ringing anyway, and I was like, oh, I might as well just pick up and...
I'm sorry.
No. Don't apologize about that at all. It's easy. It's quick. Okay. Bye. Okay, so we want to prove, or we're given that FC is perpendicular to BE, and we're given that EC is perpendicular to AD. So maybe going in there, there's a lot of things going on, but FC is perpendicular to BE. And then you can go in with a different color. I hope maybe some of you are using this strategy to keep things straight. And then you're given that those guys are perpendicular. And then you're given that FE is equal to DC, and you're given that BC, so this whole segment right here, BC, is equal to AF. Whoa, there's a lot going on in there. And then you want to prove that triangle FAD is congruent to triangle BEC. This is a great example of the convenience of drawing your two triangles separately. So I'm going to draw in FAD and BEC. And I want to prove that those guys are equal. Realize I was given that FE equals DC, so that's only a piece, right? And I hesitate even to like put in a tick mark there. So maybe I'll just put in like a little black like squiggly to be like, okay, I'm given a piece about that. And then I'm given that all of FA is equal to all of BC. And then I'm given that AD is perpendicular to FD pretty much, and that BE is perpendicular to EC. And I know that the definition of perpendicular is that it creates 90-degree angles. That's it. That's the only definition of perpendicular. But I do know that from there, I could say that those two angles are 90 degrees. I don't know why. I don't know if it's to prove that those angles are equal or if it's to prove that those triangles are 90 or are right triangles. So we have to kind of go a little bit into this path, go a little bit into this labyrinth without like an end goal. And that's very, very normal. Just start writing down what you do know. Well, I know my given. Oops. And then I do know that within those triangles, I could then prove that those angles are 90 degrees because I've been told that they're perpendicular. Do not call it just angle D or angle E. I saw in quite a few of your exit tickets from last class that you just called it angle E. But realize up here, you have two angles at angle E and you have two angles at D, right? So you need to call it by its three-letter name. So let's call it angle ADF. $90 degrees, and BEC. And the reason is definition of perpendicular. Okay, so I've given that those are 90 degrees. I have not said yet that they are equal. I've only said that they're both 90 degrees. Do I want to say that they are equal? No, because if I said that they were equal, then what I would have between the two triangles eventually, because I'm pretty sure I'm going to prove that FD and EC are equal to each other because I know that parts of them are equal to each other. I know that that would give me ASS, which is not good unless it's a right triangle. And remember with HL, you have to state that it is a right triangle. It's one of your 3 things you have to state in order to prove HL. You have to say that it's a right triangle. So now that I know I'm using those 90 degrees, not to prove that those angles are equal, but to in fact prove that those triangles are right triangles, I'm going to write that down. Triangle ADF and triangle BEC are right triangles. And that is because of the definition of a right triangle. So I've said one thing that I need to say in order to prove that those triangles are equal. I've also proven that the hypotenuse is equal. And so now I just need to prove that that leg is equal to the other leg. And I need to talk about FD, but I only have FE. So I need to find a way to bring a relationship of those guys together, of what I know and what I need to talk about, or what I need to find out about, right? So if I'm going to bring that all together to talk about a part of a segment compared to its whole segment, I'm probably going to set up segment addition. So FE plus ED equals FD, and then ED plus DC equals EC. And that's just segment addition. So now I've talked about FD and I've talked about EC, but I've talked about them in 2 separate equations. And now I want to be able to bring them together and have them in the same equation, which means I need to find a bridge or a substitution or a transitive property of equality that will bring them all together. I have ED in both of them, which is fantastic. I now just need to figure out what to do with the extra pieces that are hanging on, FE and DC. I know that FE and DC are equal to each other, and I've already stated it in my proof up here in the given. So now I just need to go in and manipulate one of the equations to make it look like the other equation. So now I'm going to take my first equation that I wrote, and instead of FE, I'm going to replace it with DC, but still keep everything else about that relationship or about that equation the same. If I'm just taking out one small piece and replacing it with another small piece, that is substitution. Okay. Taking a look back at what we have DC plus ED and ED plus DC because of the commutative property, because of the associative property. Those are interchangeable. They're fine, right? They're the same thing. So now we're going to take out ED plus DC and replace it with FD. Now I can say FD equals EC. Since I'm taking out a whole half of an equation, that would be transitive property of equality. And now I've proven that those guys are equal. And now I can say, well, I know that those two triangles are equal because of HL. FAD and BC or CB. Is that what we wanted to prove? It is what we wanted to prove. QED. Okay, that is it for your notes for today. Yeah, that is it for your notes for today. So go ahead and get started on your homework.